video, we're going to be taking a look at continuity. And the basic question we're going to be asking is a function at a certain point continuous or not continuous? So it's pretty simple. And there's three things that you will want to look for. The first thing to check, I guess you could say, is if the limit as x approaches some value a of f of x, if it exists. So it equals some number, we'll just call it L. And the second thing you want to look for is if the function at that value a exists. And if that does, then you can check the third criteria, I guess you could say, to determine if the function is continuous at the point a, and that is if the limit as x approaches a of f of x equals f, the value of the function at a, f of a. And so once you check all three of these things, you can determine if a function is continuous. And if these 3 points match up, if you determine each one to be true, then you have a continuous function at some value. And so yeah, that's the basic principle for determining if something is continuous or discontinuous. And there are different types of discontinuity, and the first type is called an asymptote, or some people refer to it as an infinite discontinuity. So let's go ahead and take a look at that. Let's say we have the function f of x equals 1 over x minus 4. And if you've taken algebra before, you can quickly see that there is a discontinuity at x equals 4. Because if you plug in a 4 into this function, we'd get 1 over 0, and that leads to an asymptote, or an infinite discontinuity. So that function would look something like this. If we had an asymptote around x equals 4, and then it would look something along these lines. That's just a rough sketch. Yeah. So, and let me just write this down. This is called an asymptote. Asymptote, or an infinite discontinuity. Okay. So the next type of discontinuity I want to take a look at is what's referred to as a jump discontinuity. And so the example we'll use is if we have this piecewise function, f of x equals 2 plus x when x is greater than 1, and 2 minus x when x is less than or equal to 1. And if we draw this piecewise function out, it would look something along the lines of, let's see, put something there, going along that way, and put something there, going that way. So it would look something like this, where this is x is equal to 1. And so as you can see clearly, there is a discontinuity there, and this is referred to as a jump discontinuity. Jump discontinuity. And we can tell that's a discontinuity by checking the 3 principles we talked at the beginning of the video. And if we looked at that first principle, was checking if the limit exists at the value, and if we check the limit as x approaches 1 of f of x, we can see that it does not exist because the limit from the left does not match the limit from the right. So the limit does not exist, and therefore there's discontinuity. The third type of discontinuity I want to discuss is referred to as a removable discontinuity. And so if we look at this function, f of x equals squared minus 4 all over x minus 2, and we draw what this function might look like, it might look something along these lines. And so with this, if we simplify this function out a little bit, we would see that we actually on the top, it's the difference of two squares, so we can simplify it. And these will cancel out, and we're left with just x plus 2 as the function, with a removable discontinuity at the value x equals 2. Yep. And we can use one of our principles to prove that this function is discontinuous at x equals 2, because if you plug in the value x equals 2, you realize that the function at x equals 2 does not exist. So I'll write that out real fast. We have a discontinuity at x equals 2 because f of 2 does not exist. And this is called a removable discontinuity.